All right. Good afternoon. Now that I give you 5 minutes to chat, suddenly the volume went. um, good to see you all. Hi, my name is Sam Snow. I'm one of the faculty on the environmental engineering, as you probably know. So if you look at my last name, there's a couple funny things. I do have a brother named John. So if you've ever seen Game of Thrones, it's literally Jon Snow. Kind of amusing. And there's a famous guy also named Jon Snow, but with a John, who was famous for the first guy that really studied disease traveling through water, so waterborne disease, back in the 1850s. So he didn't have any children, so I'm not directly related, but maybe he had a sibling or something. So who knows? Anyway, I've been here for about 8 years. I grew up in Georgia, kind of outside of Atlanta, and then went to Michigan for a couple of years after doing all my schooling in Atlanta, and then moved here for this job in 2016. So wanted to kind of give you just a quick little bit about myself. I want to try to get to know you guys a bit also during the semester. Usually if there's less than 40 students, I can try to get everybody's name eventually. Not the fastest at that, so please be patient with me. So maybe if you don't mind, I could have each of you say something, kind of say hi, and then say something about yourself. You here for EVEG? Yeah. For 31:45? Yeah. Yeah, okay, so the room, somebody's in there for like 3 hours, and we had no idea, so we moved here. All right, so today my goal is to kind of say hi to you, obviously, to talk to you about the syllabus, show you the Moodle page that I just activated like an hour ago, kind of give you some updates about what the course will look like, what I'm expecting, just some background like that. And in a minute, I'll have you guys kind of share just a bit of who you are, your name, all that kind of stuff. And I might, for a few classes, just go through the roster a couple times just to say, okay, orient your face with the names that I'm seeing on my spreadsheet, right? So again, please be patient with me on that. Okay, what was I about to say? We'll come back to it, whatever it was. All right, so let's begin. What's your name? And maybe some interesting, where you grew up or some interesting thing about you.
I'm Jacob. I'm from Baton Rouge. I was originally born in Chicago.
Okay. And by the way, I think we have maybe 2 or 3 petroleum engineering students. So if that's you, let us know, or that could be your interesting fact.
I'm Braden. I'm from Maryland.
Okay, that works. Where you're from works. That's good.
Yeah. I'm Jack. I'm from Baton Rouge.
Okay.
I'm Matthew. I'm from Illinois.
Great.
I'm Jacob. I'm from Mandeville. I'm Steven. I'm from Mandeville.
Okay.
I'm Lily. I'm from Philadelphia. I'm also Lily, and I'm from Versailles, Kentucky.
Okay.
Macy. I'm from Slidell. Brooke. I'm from New Orleans.
Okay.
And Josie. I'm from Houston. Elise. I'm from Florida. Natalie. I'm from St. Martin in the Caribbean.
Okay.
Gracie from Homa.
I'm Noel. I'm from the Dallas. Patrick. I'm from Louisville.
I'm Kelsey. I'm from New Orleans.
I'm Mason. I'm from Baton Rouge.
Okay.
Andrew. I'm from Thibodaux.
I'm Mia. I'm from San Antonio, Texas.
I'm Tyler. I'm from Slidell. I'm John. I'm from Mississippi. I'm Marcellus. I'm from Baton Rouge.
I'm Danielle. I'm from Houston.
Awesome. Thank you. So do we have petroleum engineers in here? Is that right? Anybody? Not to put you on the spot. Okay, maybe not. There's also a chance that like whatever spreadsheet I was given with the thing was just either wrong or just like maybe somebody transferred. I don't know. Okay, so maybe not. So probably all EVEG then, right? How many of you feel good, bad, ugly about chemistry? What do you feel? Mediocre, okay. Anybody deathly afraid? Kind of some thumbs down. Yeah.
Would it be more like pertaining to organic chemistry or physical chemistry?
Just generally, I was asking, but that's a good question because In this class, it'll be a little more inorganic, a little more kind of acid-base equilibrium type chemistry. We might touch a little bit on organic, but not so organic for this class. Okay, what about coding? Any of you ever touched any computer programming at all? A little bit? Anybody done any MATLAB? No? Okay, so one of the things I'm going to have us do at least a little bit is learn a bit of MATLAB. I realize that we don't have a formal course within our program here. I think it's a really useful tool. Thankfully, there's some really good short resources, kind of like self-paced online learning modules that the MATLAB software company provides. So one of the things we'll talk about today is kind of, we're going to go through just a bit of that for the course, do some very simple things, and then kind of relate how we can do some of the more intense computational chemistry with a software, and we'll get probably just to the point where we could see how we could do that with Excel or with MATLAB. Any Excel whizzes in here, by the way? Anybody like really feel like mastered Excel? No? Okay. Anybody like terrified of Excel? Okay. All right. So on that note, I've got a little thing I'm going to pass around. I'm going to explain this in just a moment. Just a little feedback, to get a little feedback from you. Okay. Just a little survey. You can, if you felt like you needed to be anonymous, just take one back. If you felt like it needed to be anonymous for whatever reason, you don't have to put your name on it. But if you put your name on it, then I'll get to see, oh, okay, so-and-so is really feeling good or about this or really interested in that, right? So it's, you'll see I just have a little questionnaire. How do you feel about these topics? How do you feel? What are you interested in? So just like to get some feedback from you. There might be extras, yeah. Don't worry about that. All right, so appreciate that, and feel free to add to that or continue working on that for a moment. Just a little bit more about me and why I'm here teaching you, and kind of a bit about the class itself and everything. My research expertise is mostly disinfection technology related. So clearly that's oftentimes chemistry. My own specialty is more like photochemistry, so UV light and reactions you might drive with, have light-driven reactions, photocatalysis, stuff of that nature. Certainly gets me into the chemical realm, but it turns out that most of the time I've been here, I've been teaching EVEG 3110, so water and wastewater treatment, more so than this course. In fact, I haven't taught this course before. I taught the grad level of it, version of it last semester, and that was my first time teaching that one. Of course, in water treatment and in other courses I've taught, it's kind of neighboring the general chemistry for environmental engineering is maybe what we could call EVEG 3. but I haven't taught this specific course at the undergraduate level yet. So I say that to ask a little bit for your patience and to let you know I'm also going to be calibrating my expectations as we go, which is good news for you. If I make some sort of mistake and make something too difficult or too much, I can scale that back, right? So I'm going to be working with you on that to make it a meaningful course that's not trying to like make it way too theoretical or anything like that. So that's my aim. I think I've got some decent organization so far, but I definitely know that I need to kind of revise as we go, and hope to do that and keep it pretty well organized for you. Okay, I do something interesting when I teach. I record all the lectures. In fact, I don't just record them, I'm live streaming right now. In case there was somebody that was sick and couldn't be here or something like that. It's something I started way back during COVID, and let me just get to my page here. And I just found that it was the kind of the most convenient way for me to lecture in this sense is to just live stream it instead of try to go on Zoom all the time. So I'm going to pull up YouTube so you can kind of see if it'll let me sign in. Okay. Part of why I was trying to be here a little early was to get all this stuff taken care of. Of course, then the classroom switch threw a bit of a loop. And now I have to verify, yes, I'm trying to sign in. Blah, blah, blah. Okay. All right. So I just want to show you in case, one of the things you'll have available to you is recorded lectures. So whether that's you wanted to study for an exam and you wanted to go back through the homework, or you wanted to see like where to find this, I wanted to give you a quick look. So on Moodle, which I will pull up also, I have a link to my YouTube channel. It's actually a link to a playlist that I'm going to upload these to. So if we go to YouTube for a moment, you'll notice we could take a look here and we have some video inception happening as soon as we look at this link. It's going to be here pretty awful if it's actually going. See, there you go, and the sound's on. All right, so if you wanted some more crazy headache, this is what I'm looking at on my screen. This way I can, the whole point of this is that I can, oops, not do that. I can look at what I'm teaching you and have a little writing pad here. So it's kind of like I'm writing on the whiteboard without doing any of that. Okay, so all that's to say, I've got some resources built in for you here. I'm going to wear a weird little glove and be able to write on the slides like this, and then I'll post the slides for you with my notes on them. My aim will be to have a blank presentation if you wanted to bring a device and take notes yourself, and then I'll give you whatever I'm writing up there as well. So, and I'll just replace one with the other once I post it. Okay, so that's kind of the format you can expect. But that also means that you might also all be thinking, ooh, I could just not show up to class, right? If it's just online. My expectation is that you are showing up to class, okay? I'll just say that flat out. If you have an occasion where you need to miss for some good reason, I'm very happy that you have the resources to catch up, right? So if you have an interview for a job, or if you have some family emergency or something like that, I'm a little more lenient. You know, I'm not going to be so obstinately like, you must have a medical excuse, right? That's kind of the flexibility I'm giving you here. And if you are online, you can actually chat in the YouTube live chat, and I will see it here and be able to answer your questions. So if that were the case, if you had the flu but still wanted to attend class right then, you could be live and ask me questions, and I'll bring it up to the class because I'll be able to see it. So it's really handy. I don't have to think too hard about it. It just takes a couple minutes until something needs to update, or every once in a while there's a small issue, but that's, I think, going to be helpful for you. It's the way I'm doing things. If we're just getting like 2 students in class every day, then I will certainly be taking attendance. I don't expect that. But you know, it's usually not a big issue. Just my expectation is that you are going to either attend or let me know what's going on and why you have an absence. Okay, so that's kind of typical for most classes. I do kind of reserve some, I think, in the syllabus, which we might as well go ahead and start talking about. I think I do say here that I reserve the right to take off credit from the homework categories if I feel like your participation was just completely lacking, right? Okay, so enough about that. Class in general, I have kind of the basic information here. So my office is in PFT. If you know kind of the civil and environmental section, right next to Dr. Mo's office, kind of down the hall, right past that little intersection. I can certainly make time for office hours. I don't have a dedicated time at the moment, but feel free to let me know if you needed to come talk. Happy to do that. I expect that this is going to change given today's situation. Perhaps to here, but I'll try to get clarity before our next class period and send out an announcement. I guess we might be in here again, but we'll just have to see. Okay, have not mentioned the textbook. So we have a textbook that's available in the library. So I don't think you have to pay anything for that. And I think it's just, you can follow that link and have access to it at your leisure. Now, I will say that last semester when I developed, this is strange, I developed course materials for the related course. I was trying to figure out which textbook to use, and there was like 3 different ones. And so some of the course material might come from different places, but that's going to be the one I'm following along with kind of in order for the most part. I also have an older textbook, which is the second recommended one there. I'm going to figure out what's up with that text. It's a lot better scoped in terms of, you can even just see the size. For a more of an introductory class on environmental chemistry. My undergraduate was actually not engineering, so I'm kind of not an engineer. My grad degree was engineering, but I was in a program called Earth and Atmospheric Science. And so this is a book on geochemistry, which is very, very related to what we're doing, but a little more focused on natural sciences. So in our class, I'll pull it a little back closer to engineering. And I'm excited because I had lost this book because someone had borrowed it, and I got it back at the end of last semester, but in time for you guys, that I can have a little more, I hope, practical, hands-on, kind of the right scope of a problem rather than trying to get too theoretical. Okay, so that's that second book. It's a bit older, but if you wanted it, it would be a good resource. Okay, course objectives, and this is kind of on the first PowerPoint slide also. Basically, we want to be able to do that quantitative chemistry that we need to for our environmental engineering systems, right? How do we know how much chlorine is going to be in one form or the other? How much of it's going to dissolve if we add in a chunk of calcium hypochlorite? How do we think about that? How do we handle it? How do we deal with the redox chemistry involved with changing iron? Iron rusting is a redox reaction. It goes from 0 valent to an oxidized form, and then it turns red, and so we see the rusty red color, right? These are the types of reactions that are important in a lot of our systems if we're trying to treat our water or trying to understand what's going to happen in the groundwater if we do some remediation or if we're pulling up well water, all sorts of systems like that. Okay, we also want to be able to have some way to predict or kind of understand a little bit. If I gave you some information about a particular chemical, do you have some idea then of what that's going to do in the environment, right? We want to kind of build on some of those core concepts. Oh, this thing's very oxidizing. What does that mean? Oh, it's very reducing. what does that do? Or which kinds of chemicals tend to be that way, right? Something highly oxidizing, we can think of fire as oxidation, right? Or an explosion is typically an oxidation reaction where something's rapidly oxidizing. So as we go through the course, I'm hoping that you can get some of this general knowledge, kind of osmosis into your brain. Oh, if it's an oxidizer, it's likely to cause something to burn, or it's going to strip away the electrons from something else. And that often is a reaction that releases energy if it's favorable. We'll talk about what's favorable, what makes it favorable, what makes it not favorable. And then also kind of communicating that in multiple formats, and this is sort of where I'm adding in the MATLAB. There's another program we might touch on a little bit where it has a lot of chemical systems built into it. It's called Mintech, and you can go into it, and it's a standalone program where you can go in and say, oh, I want a speciation diagram for this, that, and the other for the, I don't know, copper solubility in water. And it can help generate some of these plots we're going to look at in our class. So we'll have some exposure to that, including some exposure to MATLAB and Excel. Not planning to go too crazy on that in general, but that's going to be something that I hope will be beneficial. So grade-wise, we're looking at kind of 5 categories. Two of these categories are kind of homework related. So one will be the more conventional homework, solve some chemistry problems, describe what's going on here. And each one will correspond with an exam so that it's kind of preparation, a way to study for the exam. We'll go through those solutions as kind of exam prep. It's kind of a pretty typical or straightforward way to go through it. We also have 3 exams. Right now, I'm not planning for the final to be particularly cumulative, but given that we're learning chemistry and we might use some of the same concepts, there's a good chance that it'll be a little bit cumulative in that sense. But I'm not planning to call back to prior topics specifically. I just think they might be used a little bit in the last topics. And then we have these MATLAB learning activities. So some of these, and I'll show you a couple today, some of these will simply be most of these actually will be simply go through this online course, and it gives some estimate of how long it takes. I think the first one is a big intro to MATLAB, and it says it takes about 2 hours. It might take a little more than that if you stop and tinker with things. And so what I'm planning to do, and actually I'll pull up Moodle as I'm talking here. What I'm planning to do is set these up so that you've got like one of those courses due in a week and a half from now, I think, that first one. And then after that, about every week, except not when we have an exam, there's another like 1 hour course to complete over that week. I might extend some of those a little bit if I put in some assignments involved as well. So maybe we have a basic MATLAB thing to say, okay, here's how to calculate a line and plot it. Then maybe I'll give you a small mini assignment to do so, or maybe I'll just do that in class. So I'm gonna think a little bit about how exactly I am structuring those smaller assignments. And by the end of the semester, what I will do is have you write a small bit of code that can do a chemical calculation, essentially, and then plot the result. So my hope is that it's kind of small building blocks, and you could always go back onto these training resources that you have and learn to code just a tiny bit. And it really should be manageable for you. Okay, so I'm gonna bring up our Moodle page, show you what I'm talking about with that. All right, so we do have a Moodle page now. I think it's mostly in order. A lot of the lecture materials and things are hidden for you so far because I need to update them, and I'm going to do that as we go and as I prepare each lecture. But right now the syllabus should be here. If you click this should bring us to the playlist where I will post. I'm just going to like they'll be on my YouTube page. I should explain that real quick. The videos will be there under the live category, even if I have not yet put them into the playlist. So as soon as we are done here today, it'll be there. So if you go to the channel, if you click the link, it should probably take you straight over to the playlist that I'm going to fill in here. But if I just hadn't gotten to it and you still wanted to see that, you just go to the live, and then whatever the most recent live one will still be there, right? So it'll be there. Yeah.
Is the channel name just Sandal Snow?
Yeah, it's at Snow's Lab, I think. YouTube.com/@SnowsLab. Okay, so that's the easy way to get there. You can also just click that playlist. I just want you to know, if I didn't get to it yet, you still have access. It's up there. Okay, good example here. The course intro, these will be the slides that I started to go through. I'm talking about a lot of other stuff, so it's not too much slides today. And then after we're done, whatever I scribbled on there, I'll repost here, and you'll have that as kind of the slides. And we've got each section, that's kind of the plan. I'll go through them. For the exams, I think I'll probably give you some sort of formulas and at least the periodic table out. So whatever I plan to give you for the exam, I will post here and publish that, make it, unhide it basically. Right now it's from the grad level class, and you probably don't want to look at that. Okay, so then we can take a look. I will make homework assignments. I have not, like I said, we'll have 3, but for now they're going to be hidden because I haven't formulated those yet. For the MATLAB, go ahead and go to it now. The instructions to access it. So each of you have the chance to get free access to MATLAB through LSU College of Engineering. So that's actually really cool. So I highly recommend you go ahead and, as a first kind of homework assignment, and I think I put this as an assignment, so to speak, or a suggested completion date, to go here. This is just a Word doc. Follow those instructions to get it. And I suggest doing that within the next week, so that you can kind of see what's going on, have MATLAB, hopefully by Thursday. I think Thursday maybe I'll even bring MATLAB up and show you a little more about it. Maybe we'll do that today if we have time. But a little more importantly, then we get to these assignments down here. So MATLAB on-ramp, this is that first one. It is now assigned. I'm asking you to have it done by January 28th. So 2 weeks from now. Next up would be the first core skills, then another core skill course, and you'll see it's about every week approximately. Not every week throughout the semester. It's kind of front loaded right now, so I might sprinkle in things and push things back a little bit. And so far I've just put them as due by midnight of that particular day that we have a class. In general, what I'm looking for on these is a completion, that you've done it. So I'm not going to be terribly fussed if you submit it the next morning or something like that. If you're getting behind on everything, that's going to be a problem for you regardless, and that's an issue. So I wouldn't be 2 weeks late without talking to me about what's going on, right? Don't do that. But if you happen to be 5 minutes after midnight, I don't care, right? That's fine. It should still let you submit it. And these, by the way, as we'll see in a moment, it will actually let me go ahead and bring it up. So when you go to the page here, it may ask you to log in. when you download MATLAB and when you access it through LSU, you'll have some sort of login that you create and you'll be fine. And then you can go to this. So this one says it's about 2 hours. You can go ahead and say, okay, I'm going to start taking it. Okay, I've already done this. Okay, so you would have to sign in, and then you can start your course. And you start it, there's going to be some video, and it's going to also probably task you to do some things. I think it also brings up a web version of MATLAB that you can use. Like I said, it's a great opportunity to download MATLAB itself, but there is some web capability that through their website. So if you really want to, you could use that.
Hello and welcome. In this course.
Okay, so as you can see, there's opportunities there. And that's just a little bit about what that's going to look like. Now, once you've done that, and you've completed the course, the technical assignment that I'm giving you is to go here and say, share the certificate of progress. And all you need to do is just grab that PDF and say, hey, look, I did 3%, right? Now, I would like for you to be doing closer to 100%, right? Now, I don't think anybody is this case, but if you happen to have already taken a whole bunch of MATLAB and have no need for any of this, let me know and prove it to me or something, or we'll talk about it. And don't worry about it, right? I'm not here to waste your time if that's the situation, but I'm assuming that you have not, and this is going to be a participation activity. So if you're consistently submitting 70% completion, well, it's probably going to show in your other stuff, MATLAB assignments, but I'm also going to see that and say, okay, well, if you're only participating that amount, that's your participation grade for this section of, coming back to our syllabus, that would go into this grade, right? Okay, so that's something to do. And I think right now there's maybe 6 or 7 of those. The first one's 2 hours. I think everything after that's like an hour or less, or somewhere around there. So that means you've got a fair amount going on outside of the other homework. So I'm going to try to make sure that the homeworks are not like overly involved. Okay, so and because I recognize that that's kind of a lot of assignments or a lot of activity for this course. But you let me know if you are struggling with this or if you are having some particular issue or anything like that. Communicate with me, right? I want to know that. Another thing I can and probably will do is bring up MATLAB and kind of walk you through a few pieces here in class. Okay, I'll bring up the program, but I'm not going to do anything with it today because that way, if you would like to bring your laptop next time, you can come prepared and kind of tinker alongside, right? So maybe I'll do a very simple, like, let's plot a line, okay? All right. Okay, I think that's about everything I wanted to show you on Moodle, probably. Get back to Moodle. Okay. Good enough. All right, so that's kind of the big picture of the course. Here's MATLAB finally. Guess we'll take a look at the course schedule in a moment. Just pulled it up so you can kind of see, okay, here's some code, here's a few scripts over here. Like I said, it's a program and we can write code with it. We'll talk a little more about it, and on-ramp will really be a nice, easy way to familiarize yourself with, like, hey, what is this? How do we work it? What's going on here? So not going to go any further on that for the moment. Okay, last thing on the syllabus I'd like to say, or really highlight, is the tentative schedule. I will try to stick with this. Oftentimes there's some interruption here or there, or I might get ahead or behind on something, especially since I haven't taught this specific course. It's not streamlined for me yet, but this is my plan. Go through some of the intro stuff. We'll talk, I think I have 2 slides on water as the universal solvent as a course content for today. Pretty theoretical, but kind of gets our mind spinning about kind of the very basis of aqueous chemistry, the water, right? What's up with that? Okay, then some thermodynamics, chemical equilibrium, that leads us into acid-base stuff. We'll probably have some MATLAB sessions here and there, or at least partial. Also some practice sessions just to work problems together. I'll try to sprinkle those into the lectures themselves also, but we may have a dedicated class or 2 for that. Of course, exam review will be basically that with the homeworks. Then we'll have an exam a couple weeks before Mardi Gras. Then we'll start working on kind of the graphical solutions to these pH versus concentration diagrams. That'll make more sense when we look at them, but basically there's some cool things we can do just by graphing the equilibrium stuff. And we can figure out specific key critical points, or when does something dissolve, when does something precipitate. Stuff like that we can graphically look at, and the computer programs are what helps us to graph that and not have to struggle and do a very long, complicated equation type solution to a chemistry problem, and then have to do that 10 times for 10 different pHs to try to figure out when does this thing dissolve. You know, that's what we want to avoid, and that's what we can graph. We use these graphs for. Okay, then we'll go on to titration and buffering, then some discussion about metals, metal complexation, have another exam, and then look at a little more metals in terms of dissolution, but probably minerals in general, dissolution, precipitation, redox reactions, how those also relate to the metals often, and probably end with a bit of carbonate chemistry. We're probably going to touch on carbonate chemistry with acid-base also, but specifically in mind with how does gas exchange with the atmosphere? How does that affect the carbonate system, so CO2 dissolving into water? And then our final exams on, so far, scheduled for May 5th, last time I checked. Okay, any questions about the syllabus? Have I scared you? Feeling all right? Have you gone back and revised, like, no MATLAB, no. Okay, I think it's going to be all right. It's surprising to me to think about how long ago it was that I learned MATLAB, but over the years, every now and then, I have some fun little project where I come back to it and tinker with it, like really not anything super complicated, but have over the years found it like, oh yeah, I could do that in MATLAB. Let me see what I can do. And it's kind of fun to think that, oh, you know, it's like a tool that I can use. So I might have a little fun coming back to it here with you guys. Okay, so with all that, I think I just want to talk a couple minutes about water. So H2O, the universal solvent. So how many of you would say that water is a lot different than some other liquid like ethanol? Do you have a good feeling for why that is?
Water can act like an acid or a base with respect to its other reactant.
Okay, yeah, so it's got acid-base characteristics, and it can do either. So, and if we think about, that's a really good point, because when we think about an acid, we're really just thinking about the proton, and think about the base, we're really just thinking about the OH minus, the hydroxide. And one of the most fundamental equilibrium concepts that we're going to talk about in class is, well, those two are going to be in equilibrium, and we're going to usually draw it the other way, so I'm going to fix this in a second, like that, right? So H2O will be in equilibrium with, is a good illustration of my the way I'm going to write on the board. I will try to make it organized, but sometimes I'm going to go back and erase stuff. But yeah, so good point. What else? Anything else about water that's like stands out to you? Like, this is weird or different or important, certainly that's a good one. Yeah.
Is polarity.
Okay, so polarity, yep, and that's something on this slide too. You have that positive charge and a negative charge here. I don't know why it's an equals, but it should be negative. I guess it's like 2 electrons that are kind of pulled over, and a positive charge. Now, how we would describe these would be partial charges. So if we want to get fancy, we put this little gamma, I think, to denote it's not a full -1 or a full +1, but it's a partial positive. It's polarized. It has one end of it is charged in one way, and then the other end is a bit different. And of course, with the oxygen in the middle, it's kind of like polar like this, right? And that certainly makes it different. Now, there are some other polar solvents, but if you look at hexanes or benzene or something, definitely not very polar. And so certainly water is quite polar, and that sets it apart from a lot. Anything else? Yeah, so hydrogen bonding, exactly. In fact, there's a lot of that on the next slide, right? So and that means that the water molecules are going to kind of be a little sticky to each other in some way. It certainly affects it. Anything else? Yeah.
It exists naturally in all 3 states.
Okay, yeah, so all 3 states, meaning like solid, we have ice, we have water vapor, so gas phase, and liquid, right? And that's within our natural environment, those are all pretty common. I mean, ice not quite as much down here, but maybe this coming week we'll find a little bit. It's going to be pretty cold Monday, Tuesday, I think. Okay, anything else about the states there? There's something very interesting in my opinion, especially in particular about ice. Yeah.
Every form of water has the same density, so that would mean like ice sitting on water, it wouldn't be the same level if it melted.
I like the direction you're thinking, but that's not actually true. So water vapor is going to have a lot lower density than liquid, and ice actually has a lower density than liquid water also. But what I just said is really important. Anybody know why or he? Right, and is that different, or is that, yeah, does anything else do that?
I don't think so.
Right. Yeah, most things when you form like a crystal solid, they end up becoming more dense, more compact. And the reason that's so interesting, or perhaps so important, is imagine for a moment if ice compacted when you can take a lot of liquids and compress them and they'll become a solid eventually. So what would happen to our oceans if water ice was more dense than liquid water? Exactly. So the bottom of the ocean would just be ice. And how much of that would be ice? I guess it depends on how much that compression is doing, but maybe just 100 feet down you start getting ice or something. So that would just completely destroy our ocean system, right? It would just be gone. There wouldn't be an ocean system. And what would that do to the rest of the climate system, right? That would be crazy. The fact that we have the situation where ice is less dense than liquid water is incredible in that sense. It allows for our entire oceanic system to circulate. It's like when you really stop and think about it, it's like, wow, that's special. Good thing it works that way. Hard to imagine what things would be like if it did. Okay, yeah, so water is pretty special. It's kind of the point. If we go and take a look at some dictionary definition of a solvent, we can say it is usually a liquid substance capable of dissolving or dispersing one or more other substances. So water we often describe as the universal solvent. So a lot of these properties, it's polar, it's an acid, and it's a base. All of these pieces, go into it being a universal solvent. Of course, there are things that does not dissolve well, things that are not very polar themselves, they're not charged, don't tend to like to dissolve in it, but it does dissolve quite a lot. So something that provides a solution. Now that's not like a homework solution, right? That's a liquid solution. Another one would be something that eliminates or attenuates something, especially unwanted. Okay, so that's a bit about water. You guys did great highlighting several factors. Here are some of the other unusual properties. So compared to some other liquids, it does have a pretty high boiling point. I think ethanol is probably like 70 Celsius or something, whereas of course water is 100 Celsius. It's funny being like in the science world, but also, you know, in the States, we switch between Fahrenheit and Celsius all the time, right? And so when I start thinking about water and like in the science perspective, I'm like, oh yeah, 100 Celsius. So it's like when I start thinking about, yeah, and I think ethanol probably boils at like 70 degrees, and then I'm like, wait a second, degrees Celsius, not Fahrenheit there, right? But I'll try to be clear on that, and that's one of those things that I hope that you all can kind of get a feeling for as well. So another little tidbit is body temperature is 37 Celsius, and we can recognize that's almost 100 Fahrenheit, right? So if that's one way you can kind of relate to, like, room temperature is about 25 Celsius or 75 Fahrenheit. So if you remember, standard temperature pressure is 25 Celsius. That's about a comfortable room temperature. Then you can remember your body temperature is 98, which is 37. A few little key points like that. And boiling point for water is 212 Fahrenheit. Might as well write it right, 212 Fahrenheit, 100 degrees Celsius. Okay, so anyway, we've got the boiling point. We've got water ice with a high melting point. So that gives us all three phases within our environment. The density we talked about. We also have, so that hydrogen bonding that we mentioned, that ties into this high surface tension. So water itself, if it doesn't really like what it's sitting on, you'll see some surface tension. So I might be able to show you the drop. Just do this on my phone. So not sure if I have a big enough drop, but if you were to do this or to take a look, you can see it's kind of doming up a little bit, the little water droplets. And essentially that's happening because the water molecules would rather stick to each other than to the surface, which is perhaps a little hydrophobic, meaning it's not a favorable interaction there. So depending on what kind of surface it is, that hydrogen bonding can make it more energetically favorable to beat up like a little ball or relax out. Okay, we talked about it being a good solvent for some things. That's especially true for salts, polar solvents, or polar compounds, that kind of stuff. Okay, so leads me to one other thing, and I've done a little bit of collaborative research with guys that do computational stuff. Pretty crazy, like molecular scale modeling of how are these molecules physically interacting if we program, this is way beyond my programming, if we program a system where it accounts for all the different forces. You know, if these were planets, we'd be doing gravity. In this case, it's more like the electrical fields and magnetic forces and whatever else at the very atomic scale. What are they doing? And there's a question here about what is a chemical bond. So we talk about hydrogen bonding, we talk about covalent bonding or ionic bonding. Really, those are all just categories of how strong is the bond. How strong is the energy between these two interacting, pulling them together. So technically, there's nothing more than just an energy difference that changes it from hydrogen bonding to covalent bonding. Practically speaking, we can recognize like you break some bonds, it's pretty irreversible. You can't go from methane to CO2 by burning it and then straight back. That's not going to be an equilibrium reaction. Once you burn it, you've got CO2 and it's gone. You're not getting back to methane unless you do a whole lot of work. But some things like water going to OH minus and H plus, well, those can recombine no problem, right? So certain bonds are just not held super strongly. So bond length can be an indicator. even water, that hydrogen bonding that we were talking about, we can sometimes describe in water clusters. So here we've got a big water cluster where there's like a chain of water molecules that are kind of interlinking, and several others that are just hanging out kind of by themselves. So there's a lot of theory that we could look into that. There's a lot, we could go into at the molecular scale. We're not going to go into, so don't worry. But I just wanted to highlight this because water is very interesting. And when it comes down to it, when we're thinking about a chemical system, the stuff that's happening is on that scale. It's on that level where some bond energy, some charge pulling stuff, some interaction is happening and allowing for the chemical reaction to occur, or to perhaps be reversed. So we'll talk a little bit about how these pieces can fit into, let's say, the thermodynamics or the activity coefficients, which we're mostly going to ignore, make things complicated. We're not going to do that. But I want to talk about them, familiarize you with them in case you needed to work with them at some point. And again, for some of this stuff, some of the best things we can do is just simply simulate it with a computer model. Okay, so we're not going to go anywhere near that scale for the class, but we will, as you now know, do some computer stuff. All right, any questions, thoughts, concerns? Feel all right? Did I scare you? All right. Okay, I think that's all I'm going to do for today, so please just pass the papers up to the front and I'll grab them. We'll see you on Thursday, and I'll make sure to announce where we're going to be.